Hey, Julian Kraus here, and I recently wanted to compare the noise performance of two preamps. To find the best way of comparing preamps and to understand what affects the noise of a preamp, I had a closer look at the technical side of things. And I have to confess, it wasn't that straightforward as I thought it would be, but I learned some very interesting things which I want to share with you. No worries, I will break everything down for you and explain it as simple as possible. Okay, first I have to stress again that this explanation is quite simplified. There is usually much more that goes into this, but to get a general understanding of how preamp noise contributes to your recording, this is the most important stuff to know. Here you can see the components of a sound recording setup. Starting on the left, you can see a microphone which is used to convert sound waves into an electrical signal. The signal then goes into the preamplifier, where it gets a boost and then is sent to the A to D converter. There, the analog signal is converted into digital values which will be recorded. As I said, we will focus on the noise generated by the preamplifier, but I shortly have to dive into noise generated by a microphone first, because this is somewhat related to the preamp noise. To keep it simple, I will only talk about dynamic microphones for now. Every dynamic microphone, in fact every resistor, has a specific impedance, and this impedance is directly related to the intrinsic noise of the microphone. This so-called thermal noise gets higher with a higher impedance. In a graph, it would look like this. On the y-axis you can see the amount of noise, and on the x-axis you can see the impedance of the mic. As you can see, the red line rises with increasing impedance. So let's say you would have a microphone with 100 ohms. It would generate this amount of noise. And a microphone with 400 ohms impedance would have a higher amount of noise up here. Okay, so now I will add the noise of a preamplifier into this graph to show you what this would look like. Yes, I just added two new lines to this graph. That's because a bipolar transistor preamp, which is the most common type of microphone preamp, actually has two different important types of noise. This blue line here is the so-called voltage noise, and this green line is the current noise. The black line is the overall noise at a given impedance. The voltage noise is just a horizontal line straight across the chart, independent from the source impedance. How low or high this line lies is solely a property of the preamp, with better preamps having a lower line on the graph than worse preamps. On the other hand, the current noise of the preamp rises very fast with higher impedances. This type of noise emerges due to the property of the preamp in conjunction with the source impedance. So now that you know the whole picture, I'm going to simplify this a little more. Most dynamic microphones have an impedance lower than 500 ohms. 100 to 300 ohms are typical. And as you can see, the current noise in this area here is always below the intrinsic noise of the microphone. This means the current noise does not really contribute that much to the overall noise. I can prove this by turning off the current noise, and as you can see, the black line at this point does not really change. So we can safely disregard current noise from now on and will only focus on the lower left-hand corner of the chart. Okay, let's say we would have a preamp that isn't that great. So the voltage noise would look something like this. Also, let's say we had a microphone with 100 ohms impedance connected to this preamp. The intrinsic noise of the mic would be this much, and the noise generated by the preamp at this point would be this much, so quite a bit higher. If you would crank up the gain on your preamp so that you can hear the noise, you would mainly hear the preamp noise as expected. Even if you had a microphone with higher impedance, thus higher self-noise, let's say 400 ohms, the noise floor of the system would still be dominated by the noise performance of the preamp, because it produces considerably more noise than the mic itself. So far so good. I think this is all what we expected. But now let's see how the situation changes when we use a very low noise preamplifier. This is what the voltage noise of a low noise preamplifier looks like. Again, let's take our mic with 400 ohms impedance and attach it to this preamp. And here you can see that the amount of noise created by the mic is considerably higher than the noise of the preamp. In this example, this holds true even for lower impedance microphones with down to around 100 ohms. Now, if you would crank up the gain on your preamp so that you could hear the noise, you would mainly hear the noise created by the mic itself. As I figured this out, I thought it was a little counterintuitive. I always thought that the noise floor of a sound recorder would solely be based on the quality of the preamp, and that the preamp would always be the limiting factor in terms of noise performance. But actually, this isn't the case. In fact, the noise performance of products with decent preamps will normally be limited by the noise of the microphone. So why on earth did I explain this all to you? Well, I wanted to show you that the preamps these days are quite good, and the noise of these can be very quiet. So quiet that the noise generated by the mic can be much higher in comparison. In that case, it's the microphone which is the limiting factor in terms of noise performance and not the preamp. And secondly, you now hopefully understand that testing the noise performance of a preamp isn't that simple after all. There are several variables like the impedance of the mic and the technical properties of the preamp itself. And keep in mind, this stuff then usually varies with frequency and temperature, and I didn't even mention the usually negligible so-called flicker noise, so we just scratched the surface here. Nonetheless, in the next video I will go over 3 common methods of testing the noise performance to compare one preamp to another. Spoiler alert, 2 of these methods actually are not really useful, and I will explain you why. The third method, in my opinion, is the most appropriate method of comparing noise performance between preamplifiers, and I will explain in detail why I think this is a suitable testing method. Before I end this video, huge thanks to Uwe, the electrical engineer who answered all my questions about preamplifiers and made this video possible. He even built this interactive chart for me so that I can show you all of this. If you are interested in electronics, you can visit his website where he documents the things he designed and built, including a very low noise preamplifier, analog to digital converters, and an 8-channel EQ. Okay, I hope you learned something, and I see you in the next one.